Military innovation has always and will always be a struggle between forward-thinking product development, advancement of industries and sciences, and backward compatibility. It's an operational necessity that things be able to use over multiple generations, that they be able to be used in multiple scenarios. Again, back to the Brentronics challenge. You're limited by program of record constraints. As a perfect example with an operational battery, if you could give them double the power with only a 1/4 inch of growth on a 2590 battery, you can't do it. You can't grow a 1/4 inch on a 2590 battery because it won't fit in any of the radios. And so even with a huge revolutionary change, you can't adopt it because of the program of record constraints. And the real challenge is the requirements, which seems to be a real theme here in the Innovation Corner, is the chasing of the requirement. The requirements are usually dictated prior to advancements. You're going to have a very well-meaning group of people writing requirements based on what they already know about. And it can predate, or post-date, I should say, the advancements that are occurring, as Jaron was mentioning, in commercial industry, where you're going to see the people have been doing this for years in the commercial off-grid power. We're just now getting around to it in the military. But it does have its benefits. One of the key benefits to it being that today's high-energy rechargeable battery is usable in a Vietnam-era HF radio. And it significantly improves the capability of that radio, its duration, its longevity, and its rechargeability in the field using advanced recharging systems, which really is a pretty significant benefit. This backwards compatibility for decades and decades does have a lot of value. Brentronics was established in 1973 as a battery manufacturer. Built alkaline batteries, nickel metal hydride, NiCad, and eventually lithium cells. And the focus on the next challenge, the next chemistry, the next breakthrough from a battery perspective and a manufacturing perspective has allowed Brentronics to continually advance the industry. They've been at the leading edge of the operational batteries, and you've heard about quite a few of them. In the 1970s, anybody remember a PRC-6 radio? Probably, there's very few people here that could actually have used one. I've seen one. It was in like a radio museum or something, but I've never used a PRC-6 radio. But all of those radios were non-rechargeable. You take the battery and you throw it away. This particular battery, is otherwise known as a lipstick battery, is still in use for strobes and personal locating beacons. Incidentally, Brentronics still manufactures it. That was where they got their start, building batteries for the PRC-6 strobes and the personal locating radios for SAR. In the 80s, they moved towards the PRC-77 and the SYNCARS radio and developing NiCad solutions for them to make certain applications rechargeable. For example, if you had a Jeep or a Humvee as they were coming out, you could have a rechargeable battery on a battery power system. And if you lost power to the Humvee, you'd still have a holdup for the system. In the 80s, they'd already started working on the 90s, sorry, they'd already started working on the first approved combat lithium-ion battery. So lithium-ion is a buzzword that's going around today as something of great interest and that we all pay a lot of attention to. And in the 90s, Brentronics was building their first lithium-ion batteries. It also had the first state of charge indicator. They'll let you know from looking at the battery what its state of charge was, whether it was a good battery, whether it was something you could trust and take into the field. And using that past performance of decades now of battery innovation and utility with the military, they won the OmniCharge contract and began developing what would be the lithium-ion replacement for the 5590. As anybody, I'm sure we have a couple of people here that are intimately familiar with the 5590, but it's a very high-quality battery with a lot of energy density, significant energy density, and it's been our main battle battery for a long time. It's a primary battery, which means you can't recharge it, but it's the backbone of all special operations forces and anybody running radios, but you throw the thing away when you're done. Today's energy challenges, especially challenges to innovation, are that we have higher expeditionary energy challenges than ever before. At least half of the briefs that you're going to see today are adding an energy draw to the battlefield. It's a new piece of electronic gear. It's a new UAV. It's a new light. It's a new something that you're going to have to charge or find power for. Modern electronics have invaded the battlefield. Are any of you familiar with the TSOAs or the TE exercises that have been discussed, other than the TSOA TE ninjas that are around here? Every one of them adds a tablet to the warfighter. Every one of them adds a new radio waveform. Every one of them adds cords, cables, chargers, proprietary batteries, you name it. It's coming, we're going to have to deal with it. C4ISR demands energy in austere environments. There's going to be multiple briefs again on sensor systems that are left out in a field for weeks on end, and you're expecting them to have power, be able to operate in all sorts of temperatures and conditions. And these are devices that simply can't run off of a generator. They're expected to be extremely clandestine, blend into their surroundings, and be there. The demand for rechargeable batteries due to mandated use and operational resupply limitations. You just can't keep bringing pallets and pallets of batteries to forward operating bases where people can't carry pallets, they can carry backpacks of batteries. And then the net zero to the edge. This is where I met Mr. Garland, was at a Net Zero to the Edge conference where we were discussing the need to remove non-rechargeable batteries from the battle space and to reduce the number of different batteries that the soldier has to carry on him at any given time. To the dismounted soldier, weight is among the largest concerns. Of course, your capability is huge, but the weight that you're carrying on your back is the one that's going to ruin you. It's the one that's going to limit your capability. It's going to limit the amount that you can push forward and for how long. Rechargeable batteries are 30% less efficient than the BA5590 that they aim to replace. These are pretty serious numbers. 30% is a lot. And a 5590 is a 9.1 amp hour battery, and the 2590 is a 6.4. Now, there have been advancements in the 2590 that allow it to be in the sevens. We have 7 amp hour 2590s available through us and through competitors. But it means that if a recon element needed to take 18 5590s, which sounds like a lot probably to anybody that isn't in uniform or hasn't been in uniform. But that's a normal number for a strategic reconnaissance over a 5-day op, especially once you start adding small element requirements of carrying briefcases full of laptops, ISR devices, cameras, tablets, photo manipulation software, etc. So it's 163 amp hours total. It'd take 26 2590s to do the job. Talking about 8 more batteries when you could carry 18. That's an absurd number, and nobody's going to intentionally carry it. And so here's the 2590. You've seen this. It's a 2590. You guys have all seen this. It's the rechargeable battery, 6.4 amp hours. And there's our problem. Back to that program of record constraint. This battery is what everybody's got pallets of. This battery, which was essentially indistinguishable without a microscope or a magnifying glass anyway, especially for somebody getting on in the years such as I am, where I can't read what this says anymore. This one has 30% more energy. We're trying to find some ways to build a discriminator into the visual, this is what I've got. But the distance is huge for us. It's still a 2590. It looks the same, it powers the same radios, it's backward compatible to the Vietnam era radios. It meets the requirements to be called a BB2590, but from an acquisition perspective, we're into a whole new loop. There is a requirement for the battery, but the requirement is for the 2590. It's a force multiplier for anything that plugs into a radio. It's 30% more efficient with the same part number. So that's a familiar percentage, 30% more efficient. It's what we talked about, the lack of efficiency for non-rechargeable batteries versus rechargeable. They were 30% more efficient to be non-rechargeable. And in 2004, the best available manufacturing allowed Brentronics to build a 6.4 amp hour battery. This is more than likely the battery that you guys in green certainly are familiar with. This is the one that you've made your decisions about what rechargeable batteries in the field are like, how many you have to carry, and how they're going to produce a capability for your mission. Incremental improvements, like I said, are only at 7 amp hours. This battery is 9.9 amp hours. It is more energy dense than a 5590 for the first time in basically forever. We're missing a slide here. Oh, well, it's a really cool graph. And it shows the 26 2590s you'd have to carry versus the 17 instead of 18 of these that you'll have to carry compared to a 5590. But that doesn't tell half the story, because Brentronics and Protonics are both building solar-powered battery chargers that'll allow you to take that 17 load and possibly drop it to 10, 11, and that's with contingencies. If you can throw the solar blanket out during the day, you're hugely taking weight off the warfighter now, and it makes financial sense. You only have to recharge it 3 times before it's paid for itself. Oh, there it is. You get the idea. Obsolescence is the state of being which occurs when an object, service, or practice is no longer wanted. That's in bold for a reason, even though it may still be in good working order. There is a lot of things in the military that are 20 years old. Actually, basically most of the people in the military are 20 years old. But they're using gear that was built before they were born. And it's because it's high quality gear. It's high quality stuff that will stand the test of time and that will still work into different presidential administrations. But it's not wanted anymore. They want new solutions, even though this old one does continue to work. That's that shiny thing that you want to get the guy jumping up and down with the wide eyes. We're all representing that shiny thing, but we're up against these. This is a program of record. This is on our own website, listed as a state-of-the-art portable battery charger. It's 27 inches long, 14 inches wide, 8 inches deep. It's 34 pounds. It'll charge 4 2590s or myriad other batteries. I think you can plug 16 of a much smaller battery into it with different configurations. Costs about $3,000, and it's a military program of record. We're going to sell a bunch of these battery chargers this year. And we're going to sell a bunch of those lipstick batteries for strobes and PRC6s. But this is its replacement. This is a 2590 battery charger. And you could probably fit 100 of them into that ammo can. This costs $150. This was built off of IRAD. It's also very specific. This is a low-rate charger that'll charge 1 battery at a time, and you got to plug it in. You can plug it into a cigarette lighter. You can plug it into a NATO slave. You can plug it into solar. And that's it on top of the battery. Then you're looking at the whole solution. And you talk to the warfighter, and it's not a question as to which one they want. They want the one that doesn't take up the truck bed, that you don't have to carry around, that won't get run over or left behind. This is the one that fits inside your 60 pouch. And it costs, I have 300, it actually costs $150, I found out. But it's developed using IRAD, internal research and development money. The government did not give a requirement for this. This was built by Brentronics because they had the resources and they had the means and the capability and the knowledge with which to build one. And they've built a whole suite of them. This is a battery top inverter with USB ports. If you've got a small challenge, if you want to power a pad, if you want to power a laptop, I was running my laptop off this earlier today, we've got inexpensive, specific solutions that are being done at a very low cost. This is not a program of record, nor is it built on program of record money. There's a flex power generator or a power supply back there for charging batteries and Embittered batteries in specific. Folds up and puts in your cargo pocket. And this is probably my favorite of the bunch. This is an Embittered battery, which is hugely energy dense for its size. State of charge indicator that'll hold 2 USB ports, one of which is a 2 amp to power an iPad or whatever. The iPad is an unbelievably powerful energy draw within the military, because as much as we like to think of everybody all the time, putting enemies in sniper glass, the reality is at least half the time they're sitting back in a rack somewhere off, not doing their business for the day, and they need something to do. They've all got their iPhones, they've all got their iPads, and you got to power them. And if you power them with a 30 kilowatt generator, imagine walking up to a 2 kilowatt generator and seeing only a 1 amp load on it. And that happens all the time. It's why operational energy is making a movement towards hybridization, and it's why we're moving towards the spot generation for the warfighter. It's because if this is all I need, give them this. Brentronics is known for energy innovation, specifically from the battery side. We've got a rich history of being the forefront of battery advancements. Every single new chemistry that's come along, they've been leading the charge operationally and making part numbers for it. They've got a legacy advancing the operational power industry. There's a lot of really, really solid companies in this space. I'm lucky to work with many of them with Strategos Consulting. And each one of them has these really specific things that they're amazing at. These guys are building a better battery. And if you're in green right now and you're carrying batteries, you need to know about this battery. And I'll tell you a lot more about it later and how we're going to distinguish it from the others. Does anybody have any questions about specifics of this?
One of the issues with power density is the propensity to explode for these batteries. Can you talk to the risk associated with that particular configuration you've built?
Absolutely. Jaron is a perfect example, described to me recently that all of operational power with lithium batteries in particular is a juggling act to whether it's a risk to the battery or a risk to the operator. You can have chemistries that will be a risk to the battery, that if you overcharge it, the battery melts down and that's it. Or you can have some that have what we lovingly refer to as thermal events, which is where it off-gases poisonous stuff and kills everybody in the Humvee. Military batteries always err on the side of hurting the battery, not the occupant. They want to put that load onto the battery and not create thermal events that kill everybody in the Humvee. As such, most of these battery configurations are extremely conservative. They're having charge rates that are well within their range of possible charging. And as a perfect example of that, and as a perfect example to chasing the requirement, I asked Brentronics 2 days ago what the fastest one of these batteries could be charged by with an existing technology, with an existing battery chemistry. This one takes about 4 hours, thereabouts, 4 hours to charge. They can get it down to 45 minutes safely. But it's a specific type of cell built by a specific manufacturer with a specific type of management system that will allow it to do that. That'd probably be a lithium iron phosphate to be able to take that kind of a charge that fast, which is what Mr. Rothkopf's using in his solutions. But I can't speak to that specifically. They're also doing some pretty amazing things with lithium cobalt. But the answer is it's conservatism. They throttle everything way down to where it's safe. The battery itself isn't creating that much of a risk.